Hello everyone. So today we are going to discuss about the genetic algorithm. So one of the genetic algorithm is one of the optimization techniques. So genetic algorithms are the simple, derivative-free, effective, and quite proposed in solving optimization problems inspired by the laws of natural selection and genetics. It's one of the very simple, derivative-free algorithms. So this is genetic algorithm. So here the first step is initialize the random populations. So we have to select the population size. So whether it is 5 or 2 or in 6 or in 10. Okay, based on our applications, we have to initialize the populations size randomly. Then here the genetic algorithms, and there are three main operators. One is called as selection, second one is called as crossover, and third one is mutation. Okay. So there are different methods of selection is there. Similarly for this there are different methods of crossover and mutation is there. So based on our application we have to select the any one method from selection, crossover and mutation. So after that we have to check that values with the stopping condition. If the stopping condition we have met the stopping condition, so that is the program going to end. Otherwise, so this procedure is repeating. Okay, so this is the algorithm of the genetic algorithm. Okay, simple. In genetic algorithm, there are three main operators. Already I told, isn't it? So one of first operator is called as selection, or that is called as reproduction. Okay. Second one is crossover operator. Third one is mutation operator. Okay. So this is for the selection operators. There are we have to use the any one method. Okay. So very famous, normal, very simple selection method is roll-out wheel selection. Okay. The second one method is rank selection, and by using the formula we have to select that is called as Boltzmann selection and steady state selection with the help of the tournament. Okay, so we have to conduct the tournament and then we have to select. Okay, that is called as tournament selection. So these are all the methods of selections used in the genetic algorithms. Okay, so one is roll-out wheel selection, second one is for the rank selection, third one is Boltzmann selection, fourth one is steady state selection, and for the tournament selection. Okay. So these are simple examples. Already everybody is very familiar about this selection. That is called as roll field selection. So I have to rotate this roll wheel. Okay, it will be stop in the one point. Okay, based on that we have to select the. So that is for offsprings. Okay. Oh, this is for from the formula by using the Boltzmann selection. By using the formula we have to select the values. Okay. So second one operator is called as crossover. Okay. So in the crossover there are different methods of crossover we follow. So one of the method is for one point crossover. Okay. So in the crossover from the parents the offspring will be produced. Okay. I have to generate the offspring from the parent 1 and 2. So I have to generate the offspring 1 and 2. So here we have to decide after this point. Okay, so we have to cross over the values. So that is the values of 0. All the values we have to change it. Okay. So see here from this first one, the parent 1, the blue color mentioned is parent 1, the brown color is for parent 2. So after the single point crossover, see here, that is for in vertical line is there. Okay, after the vertical point we have to cross over the values. Okay, so that is brown color is moved to the top side, on the top side blue color is come to the bottom side. Okay, so this is for the single point crossover. After this crossover point chosen crossover point, so that values are interchanged. Okay, this is for the one point crossover. Similarly point the 2 point crossover. Here we have to two checkpoint is there. Okay, 2 point is there. Here we mentioned clearly. So the pink color line that is for in the border line. So in the first 5 digits, see here in from the parent 1 and 2, offspring 1 and 2 is produced. So from the parent 1, parent 2, the offspring 1 and offspring 2, the first 5 digits are in same. Okay, so the next digits, okay, 6 digit, that is we have to interchange blue and brown colors, or that values are interchanged. And similarly for the after the crossover also, second point also we have to interchange that values. Here we are having the 2 points, that's why it is called as 2-point crossover. Similarly for the uniform crossover, okay, so from the parent and 1 parent 2, okay, uniformly that values are interchanged, okay. So that is we have to decide, okay, which binary values we have to interchange, okay. So that is we have mentioned here. So that is for in green color values or interchanged values, okay. In the first values parent 1 parent 2, that is values are 1 1, so both the values are in same value, okay. So that is a no difference, okay. See the that is for next digit, that is for in sixth digit, that parent 1 is 0, parent 2 is 1, okay. So that values are interchanged here, okay. So very simple, that green color values are interchanged, okay. From the parent 1 parent 2, the offspring 1 and offspring 2 will be generated uniformly, and that values are interchanged, okay. This is for uniform crossover. So similarly for the arithmetic crossover, by using that formula, okay, so I have to find out the offspring, produce the offspring, okay. Here the weighting factor will be considered the 0.7, okay. The values will be weighting factor, here we assumed 0.7. So for calculating the offspring, so that is the formula a into parent 1 plus 1 minus a into parent 2. By using that, we know that a value, I have to apply that a value in this formula, and then I have to calculate the new offspring, okay. Similarly for the offspring 2, okay, 1 minus a into parent 1 plus a into parent 2, okay. So by applying this formula, we have to generate the offspring from the parents, okay. So that the values are in after applying the that is for in crossover, by using the arithmetic method, that values are offspring values are 0.36, 0.402, 2.33, 2.98, 0.17, 0.14, like that, okay. So this is called as arithmetic crossover, okay. So now we move to the mutation, okay. After crossover is performed, mutation takes place, okay. So mutation is a genetic operator used to maintain genetic diversity from one generation of population of chromosome to the next generation, okay. So that is called as mutation. So there are different methods of mutation also there. The first one method is bit flip mutation, okay. For example, see here, it's a original chromosome, that values are, we have mentioned the binary value 101010, okay. So after mutation, the flipping the third bit, okay, the third bit is flipped, okay. Instead of the 0, we have to use that values are 1, okay. So after mutation, that values are 101110, the third bit or after the third bit, okay. So the 0 is changed as 1, okay. This is called bit flip mutation. For next one, for swap mutation. Swap means that swap in the values, okay. Original chromosome, here for example I mentioned as A, B, C, D, E, okay. After mutation, swapping C and D, okay. So what is that? That values are A, B, D, C, E, okay. This is for after swapping, okay. So this is called as swap mutation. Similarly for the scramble mutation, okay. So the original chromosome in this scramble mutation will be considered A, B, C, D, E, okay. After mutation, scrambling the segment B, C, D, okay. So that is for in DCB, you have to mention as in reverse, okay. DCB, that is called as scramble mutation. So similar to the next one for the inversion mutation, that is invert, that is you have to mention in the reverse order. So the original chromosome is nothing but A, B, C, D, E. After mutation, okay, so that values you have to represent, okay, A, B, D, C, E, okay. So this is for inverse mutation. So D and C, that values are inverse, okay. Fifth one mutation is called the Gaussian mutation, okay. Here the original values are 2.5, okay. So by using that the Gaussian values, okay, will be considered example, the values is 0.1, okay. Add that values in the original values, okay. Original chromosome, that values is 2.5, after adding, okay, after mutation, that value is at 2.6. Okay, just we have to add this 0.1 value. Okay, this is for in Gaussian mutation method. And for last one, for the uniform mutation. Okay, uniform mutation means original chromosome, for example, will be considered 0.5, 0.7, 0.2. Okay, here the 0.2 values are have to add in the second digit. Okay, the after mutation, changing the second generation, the values are 0.7. So that is will be considered, that is for 0.2 uniformly revised. Okay, so we are getting the after mutation, that values are 0.5, 0.9, 0.2. Okay, so this genetic algorithm will be considered. So that is for in three operators: selection, crossover, mutation. Okay, so first initially I have to assume the population size, and then I have to apply the selection. Okay, after the selection method we have to apply the crossover. After the crossover we have to do the mutation. Okay, so then we have to check with the stopping condition. Okay, if the stopping condition is satisfied, so it's nothing but the program is converged. Okay, that is stopping condition is satisfied. So the that is for in end. Otherwise, again you have to repeat the same procedure. You have to apply the selection. Three operators, again you have to apply selection, crossover, mutation. Okay, so this is the operation of the genetic algorithm. Okay, thank you.